Hello, welcome to my part of the TED Talk. I'm going to describe a brief history of mRNA vaccines before my partners describe how the vaccine for COVID-19 works today. mRNA vaccines have been a focal point of medical research as of late, but they're not exactly a new idea. The earliest research on mRNA vaccines was done in the 1990s, and to begin with was considered a career dead end. A few scientists, like that of Katalin Karikó, spent a long time being rejected, as her work regarding the use of mRNA was considered too far-fetched and thus was not accepted. It was not until the recent COVID-19 crisis that it was recognized as a viable option to combat such diseases. And many have been skeptical about the applications it entitles. It was not until very recently when Moderna and BioNTech designed two separate RNA vaccines that they were noticed by anyone outside the scientific community. With this in mind, please enjoy the rest of the TED Talk.
As you may know, a virus called COVID-19 has taken the world by storm. Thankfully, we've recently developed a vaccine that we can distribute to the human population to better protect ourselves against this deadly virus. Now you may be asking yourself, how exactly does this work? Well, if you've ever seen a depiction of the COVID virus, it looks a little something like this, with proteins sticking off it. Now the COVID vaccine is an mRNA vaccine, which means that within the vaccine are strands of mRNA that are injected into your body. Once in your body, these strands of mRNA are fed through ribosomes in your cells, which then are translated into the proteins that are associated with the COVID virus. The process of translation begins when the mRNA binds to the ribosome. The mRNA is then read in sections of 3 nitrogenous bases called codons. The transfer RNA then comes in and attaches to the codons and brings in the proper amino acid from the cytoplasm. These amino acids are strung together into a polypeptide chain, which then codes for the desired protein. When these proteins are created by your cells, your immune system recognizes them as a foreign entity and attacks them. Your immune system then stores a record of this attack, making it much easier for it to deal with another invasion should you be infected with the COVID virus.
The successful creation and usage of an RNA vaccine is a breakthrough in medical science. The RNA vaccine has many advantages compared to a traditional vaccine, as it's cheap to make, it's easy to make, it's quick to make, and it doesn't require eggs or cells to be created. While it does have some issues, though, these being that there are some challenges in manufacturing it at large quantities, and since RNA is so unstable, it must be kept very cold at -70 degrees Celsius. The future is looking bright for RNA vaccines as a whole, though, as people are already trying to create RNA vaccines for viruses such as influenza.